I'm hoping you're going to ask me questions that I can't answer. That's a serious remark, because Oxford have asked me to find 150 questions about eclipses to write a book with 150 questions. And if you ask the questions and I can't answer them, great. Go ahead.
Go ahead.
Apart from people who travel along the line of totality in an aircraft, who can obviously experience quite a long time of totality, do you know what the world record is, shall we say, for stationary persons observing totality in numerous eclipses? The last I heard was a colleague of mine who experienced 27 minutes, and he claimed the world record at that time, 30 years ago, was 33 minutes.
You mean this is accumulated by going to lots of eclipses and adding them all up?
Precisely so.
Oh, right. I would think it... I like the word precisely there. I would think it's more than that, because on one of the trips, a man called Bill Kramer, who has been, I think, now to 15 eclipses. If you say on the average, they're about 3 minutes. So I would think that people up 3/4 of an hour or more. But you mentioned a plane. There was a flight with Concorde many years ago that was used to keep totality for quite a long time, for those that happened to be sitting on the correct side of the plane. And I tell the story of what happened at an eclipse not too many years ago. There was up... not the one in Svalbard, but one that was up in the north. People flew from Dusseldorf in Germany to Dusseldorf in Germany via the path of the total eclipse. And they, having bought the seats on the relevant side of the plane to see the total eclipse, the people who were selling the flight then realized that only half the seats were being sold. So they then had the brilliant idea that they could also include the North Pole on the other side of the plane. So people bought tickets for the North Pole view, and people bought tickets for the solar eclipse. And of course, what happened was everybody came over here and was climbing on each other to look out of it. I don't recommend aircraft. So that's a long answer saying I don't know the answer. Sorry.
Thank you. And
Thank you.
The gentleman behind as well.
I went on a holiday and met people who were eclipse chasers, and they said they'd been to 4 and not seen one because they'd all been cladded up, and they're hoping to see the 5th. Is that common?
Well, it may not be uncommon. It depends what one means probably by clouded out. In that, I mean, in the case of Cornwall, I was completely clouded out. And I must say that having talked to people, I mean, when I go on these ship things, it's like the Royal Geographical Society or the Astronomical Society in the States. People who are on the things have been to lots more eclipses than I have. And nobody that I've met has been clouded out in totality. So I was very unlucky, it would seem, on that score. Many of them have had clouds. I mean, I showed you a picture that I took where there was a cloud in front of the sun. My experience of being on ships, we've moved around a lot, so we were able to see it. I'm not surprised by the number you quote, but I think there must be a huge variation. I mean, you choose your eclipse sites carefully, like the Sahara Desert. I did calculate that in recorded history, at that particular time, there had never been anything other than perfect blue sky. So that solar eclipse was the first time since records began. I wish I knew what the probabilities are for the 21st of August. I have this fear that I will come back and answer your question like that. But
I think there's a question a few rows back in the centre. And anyone over this side while I'm waiting as well? No? Oh, question in the front there, Jane.
I wondered how you'd chosen your spot for the 21st of August this year. Oh. And I'm hoping I've chosen well, because I'm going to be at the top of Chairlift 21 in Sun Valley in Idaho. Ooh. So I'm keeping my fingers crossed for the answer to your question.
Right. Well, the reasons that I chose it, I hope, are good, because 40-odd years ago, when I was on my first postdoc, my wife and I, in an old VW Bug, when I had as much hair as she does now, went up to that part of the world, and it is beautiful. So even if we're clouded out, the trip to where you're going will be worth it. And the solar eclipse always, actually this is a serious remark, which I could probably address back to the question you asked about clouding out. I regard that I have inadvertently discovered a way of taking vacations in places I would never otherwise go to. And the solar eclipse is the icing on the cake, but it is not the sole reason for going. If it is, you're probably heading for disappointment. But statistically, that's a good part of the track. I think that in Oregon, there's a desert area which is supposed to be very good possibility. But where we are is what I call high risk, but in the sense that during the day, clouds and eventually thunderstorms have a habit of building up, but apparently not before lunchtime.
There we go. Question in the front there.
Okay, right. It's very appropriate that the great rock band, the previous album they had was called Obscured by Clouds.
What's this?
Yeah.
Oh.
It's a question of where it is, of course. I mean, as I say, a desert area is going to be far greater chance of you seeing it without any sort of like covering up by clouds. But anyway, good question for you.
Yeah.
What are the chances that we may be the only civilization, assuming there are other civilizations elsewhere, that get to observe this remarkable but coincidental event?
There's many ways I'm going to tackle that, which is, first of all, let us assume that there are other civilizations. It is actually a remarkable coincidence. Not only that the moon is just the right distance away, but we are here at the time when it is the right distance away. So, all the odds are against it. But given that there are countless stars with countless planetary systems, if there are any living creatures, probably there has to be a moon to stabilise it, because I think that's one of the things that stabilises our Earth, who have given it the chance anyway. So let's assume that all civilizations that are out there are on planets with moons. So your question is, what is the chance that their moon is just the right distance away to obscure the star? I'll put in a request to Tim Peake to say, that's my research project. Interesting question.
And is anyone on this side of the theatre who I've so far ignored? Gentleman here.
Do I need to take a sweater to see next month's eclipse?
I hope you don't need to take an umbrella. Your question is a serious one, which is, how much does the temperature drop? It's not a bad idea. Not least because the temperature will be significantly, it won't be cold, but relative to what you've been used to, you will notice the drop. So in the Sahara Desert, we did take, I'm not even sure now whether I did put a cardigan on, because we got so used to the idea of standing around in 100 degrees Fahrenheit at the beginning, that when it dropped down to a mere 55 to 60, you felt it. So yes, it wouldn't be a bad idea. I'll make a note of that. Must remember to take my sweater.
And it's quite difficult for me to see, but if there's anyone up in the gallery, just sort of wave furiously, and I'll send a microphone.
Yes, right at the back, there's a gentleman in a blue shirt waving. If you shout, you can probably repeat it.
Let's take this young man at the front, and then we'll go to you, sir.
How common are hybrid eclipses?
Right, well, not uncommon. If I could go back to that picture which showed the list, there was quite a few of them. In fact, the last eclipse that we saw was hybrid. Right, here we are. You could actually sort of do a quick... It's taken over. You could do a statistical... What you could do is get a copy of my book and look at that figure and, and count them up. But they're not that uncommon. The reason being that the moon... Right, right, there you are. You can sort of do the count. So, so on 2001, so there's 18 years time. So there's of the order of, let's call it 40. So in total, so hybrids, 1, 2. I thought there was a third one. Okay, 1 in 20 then. What usually causes them is that the eclipse always starts at somebody's sunrise. And at sunrise, trick question. Is the moon nearer to you in the middle of the day or at sunrise or sunset. Well, it's not a catch question, but psychologically, people often think, oh, we know this phenomenon, how the moon appears bigger when it's near the horizon, therefore it must be nearer. That's an optical illusion. In fact, the moon is further away. And the reason is, to make it silly, imagine the moon was actually only a small distance above the Earth, so that it's at the height of this ceiling above us now. Well, at sunrise, it's that distance plus the radius of the Earth. So actually at sunrise and sunset, the extra few thousand miles, I mean, the moon is, quotes, only 100,000 or more away. So the 6,000, the radius of the Earth is a significant fraction. So the moon is further away at sunrise than it is when overhead. So it is possible at sunrise that it is too far away to obscure the sun, and that gives it an annular eclipse. But very quickly as it rises, it gets within the range for it to be total. So these hybrid eclipses are actually not that unusual, that they, although only appeared to be two on there, that surprised me. I think that must mean it was hybrid. Oh, it can't be hybrid all the way through. That's daft. But anyway, it's an interesting thing about geometry. And it's, let's say 1 in 20 from that statistical survey there.
And the gentleman at the back, I believe you've got a microphone.
You mentioned during the talk being able to catch sight of the dark side of the moon during totality. Is there anything else aside from the aura that's visible only during totality?
Yes, there are. I mean, the corona itself is one example. I mean, you can make, scientists can make artificial eclipses on the SOHO satellites by obscuring the bright sun if they want to study the corona. But they're only able to study the outer regions of the corona. If you want to study the inner regions, that, I understand it, can only really be done during a total eclipse. But there are other phenomena worth looking for. Things called shadow bands, that in the moments just before totality, there's a strange phenomenon. It looks like black and white band, it looks like millions of ants sort of scurrying across the floor. If it's a light-coloured surface, you can probably sort of see it out the corner of your eye. There was a lot of controversy about whether this was a real phenomenon. It's now been established that it is. It's been taken on videos. And what it appears to be, as I understand it, it's an optical effect. You know how stars twinkle? Like a point-like source, the light gets disturbed by the atmosphere, and so it goes away or it comes in, it twinkles. Whereas an extended object, like a planet, the twinklings cancel out, and so you see it steady. Now, the sun, of course, is normally a nice circular thing, so you see it steady. But during as you approach totality, in the last moments, you've got that very thin sun, like a sort of the smiley bit of a smiley face. So in this direction, it is still extended. It isn't twinkling. Whereas in this direction, it is very narrow and twinkles. And this gives a sort of interference effect analogous to what happens when you look in a swimming pool and you see these sort of bright and dark things on the bottom of the swimming pool. And that is what seems to be happening as it comes across the floor. As you can imagine, it is very hard to do a serious study of it because you don't know if it's going to happen. And it only lasts for a few seconds while the real show is about to happen up there. And so sort of doing experiments to study it isn't that simple. But so that is one thing. The other thing I would say for people who are going to their first eclipse, if you can find a site where you've got either a good view to the west or to the east, so you can see either the approach of the moon shadow or more likely after the eclipse, the disappearing. I would recommend at the very, first of all this thing about wearing glasses to look at the eclipse, I don't think one should get over-exercised by that. You don't look at the sun. I mean, it just hurts to do so. But the one time when it is desperately important to be careful is at the end of totality. You have been looking at the sun for 3 minutes with the naked eye, or maybe binoculars, perfectly safe. And then, in an instant, daylight returns. And if you happen to be looking through binoculars at the moon at that moment, as the diamond ring suddenly flashes, your eyes, of course, now, your pupils are wide open because they're used to the darkness, and suddenly, sunlight hits your retina. That is dangerous. So it's important that somebody knows, I mean, you'll know when the end of totality is coming, you can begin to see it. Look away to the east, because what happens is your eyes are now very used to darkness. And daylight you get the impression that daylight returns like somebody turned a light on. And you can see the shadow of the moon heading off because people over there are now having their total solar eclipse. So I think at the end of totality, look to the east and you see this storm disappearing and daylight returns. And it's only then you think, where's the next one?
Thank you. Was there any more questions? Anyone near a microphone?
Do that.
Jane, have you found anyone? Joe, is there someone here? Oh, great, thank you.
I think on the August 21st eclipse, we can expect a 2.5 minute eclipse. You mentioned that the longest duration possible was 7 minutes. What are the parameters that determine the duration of the eclipse?
Well, one part of it is whether the moon, as I said, the moon goes around in an elliptical orbit. So if the eclipse happens when the moon is at the nearest extent to you, it appears slightly bigger, and hence it takes longer to get through the cycle. So it requires the moon to be at the nearest approach that it can be. And then I think from the other geometry, I'm not sure whether it has to be over the equator. It probably depends upon the time of the year as to exactly where in latitude you need to be. I think it's about 7.5 minutes, theoretically. I think by some calculations, this will happen within a second in like 6,000 AD, 6,000 something AD. The longest one in the last century, I don't know whether it reached as long as 7. It was 6 and something or other. So there's a lot of various things have to coincide, which have low probability for all of them. But once in a blue moon, if that's the right metaphor, they do.
Far less often than that, I would have thought. There's a lady behind you just had a question. Thank you.
I presume that for all the other planets in the solar system, the moons are too small to make a decent eclipse. But I thought it might not be the same the other way round, because, I mean, if you were on Mars, you could probably play at disappearing moons, because the shadow would be quite large, and so a moon could probably disappear. The little moons, you could see them in the sky, but they might disappear for quite some time. Has this been looked at and calculated?
I don't know, but as you were answering that question, I suddenly began to think, is this the answer to the earlier question about what's the chance? I mean, an interesting question, like Jupiter, where there's lots of moons and so forth, what the various sizes of those are. Somebody knows the answer. Are there any of them that...
But the other way round, you can probably have disappearing moons.
Oh, certainly. Absolutely so. I mean, the classic example there is the moons of Jupiter as viewed from Earth, which were used some hundreds of years ago. Their disappearance and reappearance was what was the first measurement of the speed of light that was used. So, and indeed, I think part of the search for exoplanets at the moment in other solar systems are the disappearance and reappearance of moons as they obscure and so on. So eclipses, not of the sun, not of our sun and moon so much, but eclipses in general are certainly very much of interest to astronomers.
Fantastic. Jane, I believe there's a question at the front there.
When you see an eclipse in the daytime, would you be able to see the stars in the sky because it goes dark?
Yes, you can. You can almost invariably see Venus because that is between us and the sun. You may be lucky and see Mercury. I have seen, those are planets, that there was a star visible, but to be honest, I didn't notice. I mean, I'm not being clever. I mean, I just didn't notice. People who knew about these things said, "Oh, did you see Sirius?" and so on and so forth. So yes, you can. The immediate area by the sun is as dark as nighttime. The overall light ambience is like half an hour after sunset on a normal day. It's that level. As you approach totality, there are some very interesting effects of shadows. You get the impression that the sun is setting as the light dims. But whereas at a normal sunset, of course, as the sun gets lower, your shadows get longer. your shadows stay the same size because the sun is in the same place in the sky. And they start getting, well, strange because a nice one, some people took a photograph of their hands like this, because I mentioned the sun, being sort of very thin and narrow in one direction, near totality when you've got the thin little layer of sea. In this direction, the sun is as big as usual, and so you don't have any twinkling, and you get sharp shadows. Whereas in this direction, it is very narrow, and it twinkles, and you get hazy shadows. I've got it the wrong way around. So in the normal day, the sun shines, and you'll see your shadow being diffused because some of it's coming around this side, some of it's getting around that side. And so in that direction, you still get the diffused shadows. But in the perpendicular direction, you get very sharp shadows because the sun is now very thin. And so you can get some very interesting shadow effects. Another thing to do is just to put some pinholes in a sheet of card and project like a pinhole camera on the ground. Or trees in leaf are wonderful. You will see hundreds and thousands of little crescent suns through the natural pinhole cameras. There's a lot one can do without having to build apparatus.
There's a question just here.
Thank you for a very interesting talk. I thought your recorded clip of the human reaction was quite interesting. Just wanted to know about animals, actually. How do animals respond, predictably or unpredictably, to eclipses? Because you can get some animals that can react to earthquakes and tsunamis and things before they actually happen.
Yes. Yes, I mean, we experienced it certainly in Zambia, that they react like they do at a normal sunset. They think, they react as if it is sunset. The surprise is, of course, at the end of totality, and the light suddenly comes back, they suddenly erupt again as if it's been in sort of catatonic state. In Zambia, we were at a camp by the side of the Zambezi River, and we set up camp on a little island in the middle of the river. The idea for that was so that during the darkness, I mean, you didn't know whether night animals were going to come out and so on. So we were on this little island in the middle of the river, and there was a couple of guards with guns and things like that. And what happened was hippopotamuses sort of started coming out of the water and walking to invade the site. But there was very strange things of the birds coming into roost and staying there. And crickets, that in warm climates you hear the cricket. You could hear the temperature changing as the crickets, or the sound of the crickets came on like it is at night time, and then somebody flicked the switch and they went off again. So it is all the things that you read and hear about animals. I mean, if you're into fauna and so forth, flowers and things are closing up and opening up. It is unusual.
So I'm just checking my watch. I think we've got time for a couple more questions. Have we got 2 more questions? Anyone? Is there anyone upstairs? Do you want to shout out? No? Let's go, gentleman there.
You said the recession of the moon had affected the periodicity of the eclipses, but has there been any effect on the height of the tides due to the recession of the moon? Any measurable effect at all over those years?
Gosh. The answer must be yes in principle, but I wouldn't know. I'm just making this up as I go along. That over that period of time, the natural topography must change. So whether the effect of tides have been more influenced by the relative nearness of the moon than other things, I simply don't know. But it's an interesting question. I'll put it down on my list. Yep. Sorry, go ahead.
So there's one final question. Okay.
So you can see in the pictures that there's a sort of sunset effect around the horizon, but considering that the sun's still in the same place and there's still the same amount of atmosphere to scatter the light, how does that work?
Well, the sunset effect that you're referring to is just normal daylight. That's when I refer to a 360-degree sunset, I was using these as words not to mean it is literally like a sunset with red light and so on. You've got blackness above you, which comes down in a dome, and then you see daylight around, and if we can just find a picture of it. If this thing, right, one more. Where's the one with the boat? Right, there we are. So that, that's interesting. One more, that. Okay, so that is, but if the darkened stuff wasn't there and all you had was the light around, so what's your question?
So it shifts more. It seems to shift more towards the red as you go down near the horizon. So it becomes sort of yellowish rather than your blue daylight shade. And because the sun's still in the same place and there's still the same amount of atmosphere, then what caused that effect?
I suppose that the amount of scattering at low angles will appear. When I'm making this up as I go along, but it's a good question. So just the geometry. When you look up in the atmosphere, you're looking through a smaller distance than when you're looking along that away. There is a geometric effect that this may appear to be answering a different question, but I think it'll come back to it. When you have a day with puffy clouds around, you always have the impression that there's bad weather over there. If the total eclipse is going to be low in the sky, it can be bad news because of what they call the brick effect. It's just simply that when you're looking in this direction, the clouds, which are indeed spaced the same as they are here, but you're looking at a low angle, and so they appear to be all banked up. And I think maybe a similar thing at the atmospheric level, that in some sense, quote, the atmosphere appears to be banked up at lower angles than at higher angles, and that may be the effect of the scattering. Certainly from the right to the left, there appears to be a difference. I mean, from the bottom to the top, that's an obvious one, but from the right to the left, there appears to be a difference. I don't know whether that is a genuine thing or at what stage of the eclipse this picture was taken as to whether the shadow is already moving into that direction. I think part of it may be an illusion by the fact that the shadow is not central on here. I think the shadow is already lower on the left than it is on the right. So the shadow itself is heading in that direction in some sense. But you've now given me something to try and look out for on the 21st of August, and I hope I have enough sky to find the answer. So it is the colour of the sunset, in quotes, light, of the horizon light, does that vary around the circle?
It's another one to write down, I think.
Yeah, no, certainly.
Well,
please have one more question that I can answer. I feel total.
So has anyone got any really easy questions?
No. A really difficult question that I know the answer to.
Joe, there's just one question there. I think we'll just end on that. Jane would tell me off if I didn't remind you, of course, that it was in this very building that John Tyndall discovered why the sky is blue, and you can see the apparatus that he used. The big long glass tube is in our museum just downstairs. So please do check that out if you haven't seen it already. Anyway, final question. Sorry.
Okay, I can guarantee you'll know the answer to this. I was wondering how many people in the room are actually going to try and go and see the eclipse in the States.
Oh, that's good. Oh.
Great.
Well done.
Well, in that case, I hope very much that the one thing you take into account was that little diagram that I showed you of how far away you can risk getting from the centre line. Stay within 10 miles to be safe, and if not, get there. And I hope we all have great weather.
Fantastic. Well, if you do run into each other, do say hello. And thank you so much to Frank for an absolutely fascinating talk.
Thank you.